Good afternoon. My name is Jakub, in case you were here in the morning. I am a software engineer at HelenOS. I work during the days, but during the night I like to develop HelenOS. So therefore my goal for today is to tell you a little bit about capabilities in HelenOS. So first of all, in case you didn't know, HelenOS is very portable. It runs on 7 processor architectures, starting with ARM, going through Itanium, as was already mentioned by Yuzi, Spark, PowerPC, of course MD64, maybe some others. And it was designed and implemented from scratch. It was mostly written it was written by us, so it doesn't contain any third-party code. It doesn't clone anything, so it does not look like Linux or Windows. And you wouldn't find someone else's code in it, basically. We like to write it in a way so that there are no huge monolithic components. So, for example, if you take a look at our networking stack, you will find several components that created that roughly correspond to the layers of the networking stack. I would also like to deliver a short update from the last FOSDEM. So last year we made 2 releases, one in April, the second one in November. The November release is the one in which we switched from Bazaar to GitHub. So you can go to Git. So you can go to GitHub and work us there. Last year we also had our regular hackathon event, which we call HelenOS Camp. For me personally, it was a very good experience because I saw new energy which came into our project. Some of the topics that I will be talking about today started there. And last but not least, we now also have a paid developer who is paid by CZNIC, which is the caretaker of the .cz domain. They have spent very close to this room and are also famous for making into this Omnia router. As for things that are ahead of us, that will be soon hopefully merged into HelenOS, there is a C++ 14 support, which will or should be ready sometime in February, and a USB 3.0 enhancement of our already existing USB stack. What you can see on the picture is a laptop of one of the USB 3.0 team members, which is of course running HelenOS and has a flash disk attached via the XHCI controller and some data is transferred from there. So that was for the update and for what's coming next. Now, before we delve into capabilities in HelenOS, there is one more thing that I would like to mention. That's Google Summer of Code. As you might know, some of the projects assembled in this dev room participated last year in Google Summer of Code. By the way, Google Summer of Code is an internship program for university students. The students work on an open source project. There are some mentoring organizations that mentor the students, and Google pays stipends to those projects, to those students. Sorry. So last year we participated. There were 3 students, one for Hurt, one for Minix, and one for Redux. All of them were quite successful, and this year we applied again. So you can keep your fingers crossed for us on February 12th, when the mentor organizations will be announced by Google. And in case the microkernel dev room is selected, then students can start applying starting from March 12th. And in that case, you can search for this microkernel dev room logo on Google Summer Code web pages. that's for the agenda. And now capabilities. So this is how we are used to talk about capabilities in HelenOS. So for us, a capability is a task local reference to some kernel object. And kernel object, it's basically a wrapper which is reference counted and points to a real thing, to something which lives in the kernel and is accessible to user space only via capability, which is referred from user space using a handle. You can imagine the analogy of VFS files where you have a file handle, which is the integer reference, where you have in the kernel the table of open files, which is basically an array of capabilities, and elements of this array then point to the underlying VFS object, which would be the kernel object. What is the motivation for actually caring about capabilities and HelenOS and trying to bring them to HelenOS? So over the years, because HelenOS started in 2001, so over the years we accumulated a certain amount of technical debt. And we also haven't always known how to do things properly, so we need to fix those things. If we also want to do some more fancy stuff like virtualization, such as the one which was presented here last year for Word, we need to get rid of all global identifiers or global names. And because we have, I think it's on this side, we have laptop stickers that say that HelenOS is an advanced microkernel system. I can't imagine going forwards without having capabilities actually. So it's also a matter of modernization. So I would like to present some examples that illustrate the need for capabilities. So here is a real example. Our goal is to pass an open file from a parent task to a child task. Both of them are clients of the VFS server. And how do we do that? So one possibility would be to go like this. What we see here is the setup that I have just described. The VFS server contains a state which logically belongs to the parent and to the child task. It's the table of open files, and it's per task. So it has a table for the orange task for the parent, and it also has a table for the child. And the goal is to duplicate this, basically the object pointed by one entry in the open files table and duplicate it in the child's table. So now you are going to see an example of one of these broken interfaces that we implemented. So what I did a couple of years ago was something like this. You can see the whole process involves 7 steps that result in the child process receiving the capability. I will briefly walk you through it, won't spend much time on it. So basically the parent starts by telling the child, hey child, now I'm going to send you a file. And immediately afterwards it says, and now I'm using a kernel recognized IPC call method, or IPC message method, IPC and state change authorized. And the child says, okay. And when it says okay, both of them identify the common server. The kernel notices the positive reply to this message and sends an IPC notification to the VFS server. The VFS server then proceeds to actually duplicate the actual entry in the parent's open file table and creates a new entry in the child's table. Then the process continues by the child querying the VFS server for the new handle, and the VFS server replies with the handle with an affirmative reply, and the child concludes the whole handshake by replying to the original first message by the OK. So is there among you someone who absolutely loves this approach? Yeah, I think so. So of course, this is rather an example of how not to do things. I myself am not 100% sure that this mechanism, even though it's a generic mechanism which allows two clients of the same server to negotiate a change of this state, I'm not myself convinced that it's actually safe and free of some race conditions. Also, there are two things to note about it. Those VFS objects that live inside VFS are not real kernel objects, and basically they all map to the one IPC entry point that exists in the VFS server. And second thing to note is the active role of the VFS server and also the kernel, which needs to send the notification. Okay, so the bottom line is we don't like this. It should have probably never been implemented. And instead, there is a different way how to do things, which is the capability way. So instead, we now have something like a table of open files, or if you will, table of capabilities that is still associated with each of these tasks, but lives in the kernel and references some kernel objects that also live in the kernel. And now the exchange is quite easy. Imagine that the parent task has a connection or has a way of talking to the child. It can be concluded in two steps. First of which is the parent basically telling the child, please connect to me, and identifying the object to which to connect. And when the child positively responds, the kernel duplicates basically the connection to the originally pointed object, and it's done. So there is a mechanism which lies in the in an IPC message, which is understood by the kernel, called IPC mconnect either to me or me too, depending on whether you want to connect to somebody or have somebody connected to you. So it's a mechanism for creating connections and callback connections. And currently, it does not accept the port number, so it wouldn't work that way in the current HelenOS. There still needs to be something done in order for it to work like this. Note how the VFS server is not involved anyhow in this transaction. And we now have a different situation when each VFS file is represented by one kernel object. There is no more the correspondence between one IPC endpoint in the VFS server and then some kind of user space kept VFS object. So that was for passing files. But there is another example which actually there is now a fix for it in HelenOS. So imagine a device driver. Device drivers usually need to register some kind of interrupt handlers. And the question is how to properly identify the handler so that it can be referred to from user space and eventually unregistered. So before HelenOS 0.7.1, HelenOS supported three syscalls. The first syscall, sysdevice assign devnode, was a syscall used to assign a device number, but it wasn't anything more than a syscall which would routinely assign a number from a global pointer and then increment the pointer. Then you could use this global identifier to subscribe your interrupt handler, which in this case is referred to by the IRQ argument. And you could also use it to unsubscribe the same. Now I wonder, can some of you spot some problems with this interface? There are a couple of problems, but I want you to think about it a little bit and come up with some potential problems that you might see. Okay, Norman.
There's the authorization for doing this operation, so that any people can do this?
Yes, that's one. Yeah, that's definitely one of the issues. So Norman asks whether, or he suggests there is no authorization for the components to do this. And okay, I won't hold this any longer. So there are a couple of problems. So first of all, microkernel should probably not be assigning device numbers, even in this stupid manner when a device number is basically a counter and doesn't really mean anything. But the more serious problems were that the API doesn't require the caller to actually use the returned identifier, and instead the caller can use any number of its choosing. So for registration it can make up something of its own, and even more serious, for their registration it can deregister interrupt handlers for an arbitrary other task. So tasks can be tasks.
Is it global?
Sorry?
GDevNo is the same number in two tasks?
It's global. It's a global ID. So as you probably will agree with me, this is completely broken, and was fixed in HelenOS 0.7.1 when we introduced capabilities into this. So we got rid of assigning the device numbers in the first place, and then modified the API so that now the subscribe syscall returns capability, which can be used by unsubscribe. So it's no longer possible for unsubscribe to unsubscribe something else, and that belongs to someone else. Of course, it can unsubscribe a different hierarchical handler from the same task. So if we can agree that capabilities are great and everybody loves them, how do we introduce them to HelenOS? And the question is that we don't have to do that because they are in a way already there, but that way is quite limited, as we will see. So now here is a picture of the basic HelenOS IBC communication between two tasks. So in this kind of pink oval, I put all the state which exists in the kernel. We have two tasks. The orange one is the one which starts the communication. It has a set of phones which are basically connections. Some of the phones are connected to other objects that are called answer boxes. The answer box is basically a message queue. Where to begin? So the orange task can basically specify the connection by a handle, user space handle, in this case 2, 0, 1, 2, which to use, then specify some arguments of the message. So the handle identifies the phone identifies the answer box. Then the receiving task can use a syscall to actually wait for messages on the answer box, and gets the call, basically receives the call, which is identified by so-called call ID. We will get to call IDs later. And then it has one of two options. It can answer the call using the call ID and some return arguments, in which case the call goes back to the answer box of the sending task, from where it can be again waited for by the original sender, which concludes the loop, and the sender gets a reply to its own message. But the recipient doesn't have to answer. It can do a different thing. It can also forward the call to someone else. So now we have three tasks. So here we see that, as I've said, the blue task is not directly replying, but it's forwarding the message using some of its own IPC connections. In this case, number 5, so it's this one. This one is connected to the answer box of the green task. And again, the green task can either decide to forward the message farther or it can reply. What is important here is that the reply goes to the answer box of the original sender. Now, how do we create new connections in HelenOS? So you need to use a dedicated method, which is understood by the kernel. And basically, if a task replies in an affirmative way to this call, the kernel notices it and creates a connection between the two tasks. So the sender was the orange task, the recipient is the green task. The kernel notices it and creates a new phone connected from the orange phone to the green answer box. It can also the direction can go the other way. So instead of using IPCN connect me to, I can say IPCN connect to me, in which case the arrow would go like this. So there will be a new connection created from the task which replies to the answer box of the original sender. And this was important to actually realize that HelenOS contains a coarse-grained capability system which is in its IPC. My claim is that this IPC is roughly analogous to the Mac IPC, even though there are some limitations that we should see. So here is a little table which kind of maps the analogies from Mac to HelenOS and vice versa. So the unit of communication in Mac is a message and a call in HelenOS. A IPC communication endpoint is called port in Mac, answer box in HelenOS. The connection is represented by a send write in Mac, while it is called phone in HelenOS. The receiving from an IPC endpoint can be done if you have a receive write in Mac and is implicitly allowed to the owning task to the task which wants to receive from its own answer box. So it's implicitly allowed. In order to answer or to reply to a message in Mac, you need to have send write to some port which accepts the reply, and in HelenOS you need to have the call ID of the accepted call. And of course, this is something that Samuel from the old project was mentioning today. In Mac, there is a way to actually pass a send write to a third party. So if there is a name service task and has connections, has send writes to some other client, it can give such a connection to whoever inquires for it. And the same effect is achieved in HelenOS by forwarding IPC connections, as we've seen in the previous slides. So the bottom line of this is that in HelenOS, the capability corresponds to a phone, and in order to pass the capability, we need to forward a connection. Now, what are the limits? Because I said it's analogous to Mac, but it has limitations. So the limitations of the state which existed like a year ago is that phones were the only types of capability. There were no other objects that were somehow usable with this. And it was only possible to pass one capability, which was like the IPC connection. There was only one answer box possible per task, which is different from Mac, which can have multiple ports owned by a task. And there were some hard limits. So there was, for example, a limit of 64 phones per task. And there was one especially annoying thing, which is the last one, that those call IDs, those are the numbers that in user space identify a call either to reply or to forward, were actually leaked kernel addresses, because frankly, can there be a better user identifier than a leaked kernel address? Sure, there can be, and we will see what it is. On this picture, which I try to draw, we actually see that there is some kind of granularity problem because of the existence of the single answer box. So even though we have a couple of objects that exist in the user space context of the server, we only have one answer box, which somehow needs to be mapped on those user space objects. And this was done by the libraries in HelenOS. So this is the past state. Now, what we have now, the situation has changed slightly because we implemented a new capability framework and started with making IPC work with it. So IPC is now implemented on top of this framework. We also introduced two new kernel object types, so one for calls. so that we no longer refer to calls using kernel addresses, but we have proper capabilities that identify a kernel object for each call. And also, as was apparent from one of the examples, we now have capabilities for IRQ objects. Unfortunately, we still have only one answer box per task, so we haven't fixed that yet. But we will probably fix that very soon. On the picture, which is at the bottom here, you can see the general structure of the capability framework. So the orange ovals, they represent the cup underbar T types, which are the actual capabilities. So if the capability is in a published state, it is visible from user space under a handle, in this case 5 or 13. And also there is an owner of this capability, which is a task called A. Capability objects, they point to k object underbar T, which contains a reference count and a type, and points to the underlying raw object, in this case it is the call underbar T. And apart from references to the k object from the k underbar T structures, there might also be references from the code. So that's the reason why we have 3 and not 2 here. Related to having only one answer box, we still, in this current situation, need to use the capability, which points to the phone, and a global number which identifies the service or the object in the server. And so it's slightly better than it used to be a year ago, but it's still not good enough. And we would like to have something like that. So on this picture, you already see that we got rid of the limitation of one answer box per task. And now we have as many as there are these library entities that were previously mapped to the single answer box. So, and with that is related the fact that now it is sufficient to use only the capability handle in order to refer to the respective destination object. And so there will be some correspondence between the C library async ports and the actual answer boxes. There will be a new capability type for them. If we do that, we could actually get rid of the phone objects at all, because now they will become somewhat redundant. Because depending on the capability right, it will be either possible to make use of the answer box capability to send messages, or to use an answer box capability to receive messages. So I think we won't need phones when this is done. And because even if we do this, there will still be 2 more objects that use global IDs in HelenOS, and that's threads and task IDs. Currently, these objects have global identifiers, and whenever an API works with threads or tasks, it needs to pass the identifier, and the kernel needs to look up and make sure that such an object exists, and this won't be necessary if we also make it possible to refer to these objects via capabilities. So the previous slide said what needs to be done in order for me to be satisfied with the situation, but there is more to come and more what needs to be done. So we will need to seriously think about resource management, because along the course of making these adaptations, I removed some hard limits. So for example, the limit on 64 capabilities per task is gone. Now there is a hash table, and it's possible to actually have unlimited number of capabilities. So now it's possible for a task to actually consume so much memory that the system becomes unusable. A similar situation is that I removed a limit which was there for the number of unanswered calls sent over one phone. So in the old HelenOS, it wasn't possible to send more than 4. If you send the 5th, the kernel would block such an attempt. And because this was contributing to some hard-to-debug deadlocks, I removed it and instead decided that we can somehow defer the problem to the resource allocator. So if instead each task has some resource pool, these limits can be basically enforced by the virtue of the task running out of its resource pool. So it will be allowed for a task to have as many active calls or as many capabilities as its memory allows it to have. So we will most likely introduce resource pools, and I'm thinking of a resource trading scheme which would be probably very similar to the one which is present in Gnode. So whenever a task requests another task for a service, such a request would have to be accompanied by some resources that the client pays the server actually with to do the actual work. Then I have some minor things that we don't currently need or use, but might seem to be useful or even needed in the future. So for example, we don't distinguish between different capability rights. At this point, all capabilities are equal that point to the same object, but as I illustrated on the example of the answer box capability that could be both used for sending and receiving, we might need to introduce something like capability rights. Currently, there is also no way to revoke an existing capability, so we might introduce that if that's needed. And we are still able to pass only an IPC connection, even though we have capabilities for other kinds of objects. This limitation might be actually removed when we have capabilities for tasks, because now it's not even possible to specify a task using a capability, but if it is, we can specify a task via a capability and another capability which should be duplicated in the new task. And that could be a new or alternative mechanism for passing capabilities between tasks in HelenOS. Or we can do a similar thing for IPC and relax a little bit the requirement that the passed object is an IPC connection, and that IPC and connect to me handshake. So in summary, I wanted to say today that even though we hadn't known about it, there was a capability system in HelenOS indeed, which was there basically by chance. I asked the developer who created IPC for HelenOS whether he intended it or not, and whether he was familiar with the Mac approach. And he said that he basically declined. He said that he didn't intend to make a capability system and wasn't even aware of the fact that it's a coarse-grained, limited capability system. And anyway, we took this foundation and extended it so that it's more generic and contains more capability types and kernel objects, to the point in which we were able to fix some of our broken APIs, fixes for some other cases like the one with passing BFS handles still needs to wait until we can have multiple answer boxes per task. And all this stuff is still quite new, is a little bit still in the flux, so there might be some time required for it to settle down and stabilize, so things still might change a little bit. And with that, I would like to thank you for your attention. There's a question.
Yes. So you mentioned that capabilities have an owner which is task, right? A few slides ago.
Yes.
I'm trying to determine the semantics of that. What does that mean exactly, that the owner is task A?
Yeah, so you basically need to think about this as a magnified version of this. And capabilities, literally speaking, are objects that exist in the context that belong, that are task local. So it's basically a reference. Let's pick one. For example, number 4 is a task local name for this P, for this kernel object. And it exists here.
So when you say it belongs to task A is the local. I'm trying to understand whether it's the issuer or the receiver.
Well, so the question was who is the owner of the capability, right?
Yes.
Well, every task has a set of its capabilities, and they might be associated with some kernel object.
Okay.
And it might be possible on these examples. I don't think there was a case in which one. Actually, on the last example, if I switch here.
Can I rephrase the question? Maybe make it simpler to answer.
Yeah, just let me finish. So here we have an instance of a kernel object which is referenced by 2 capabilities. One of them is in the orange task, and the other one is somewhere here in the blue task. Right? So there are 2 capabilities that point to the same kernel object, and both of them are in different tasks.
Yes, and that's the task in your data structure.
Well, this was just an example.
Yes, but that's a field in your task. In your
yeah,
data
there is because these entities are in a hash table, and the task. So they belong to a task, and there is a hash table. But so they belong to the task by virtue of being in that task's hash table of capabilities.
Okay. So it's the opposite. I mean, there are at least 2 ways to do it.
Yeah, there are probably many ways to do this. Norman, do you have a question?
Yes, so this is a quite fundamental change, at least it looks like this. How much was the impact on your user level code could have? So was this triggering a rewrite of certain part of the code, or could you maintain API compatibility?
So there is a question about the impact on the existing code, whether we had to rewrite lots of code. And the answer is no, because we did that slowly and gradually. So we first converted the IPC framework to be using this new capability stuff and preserve the functionality which was there. In fact, we are still removing some weird kind of reminders of the old system. So we are still cleaning up. And the other changes, such as removing the kernel addresses for call IDs, that was quite straightforward, and I just have to fix only a couple of places. Of course, it takes some debugging and some development, but we are now talking about the order of like a couple of evenings, basically. But this reminds me something that I didn't mention. When we will be able to have multiple answer boxes per task, it will naturally lead to a more object-oriented way of programming. So we will lose this granularity problem, and it might change actually the way how we write or how we look at our servers.
But so far the changes were contained to the libraries, to the common libraries in the first place, not there was no major changes in the servers themselves. Right?
Yes. Yeah, so Martin said that these changes were confined to the kernel and the libraries, and there are no other changes in the servers themselves. That's true. Okay.
It's a follow-up to the previous one. You have the capability to say, I mean, you can have the capability to mention task A can send a message to task B, right?
Yes, and such a capability, so the question is if I have a capability which allows the task A to send a message to task B.
Yes.
Yeah,
And what does it look like?
And such a capability is, so we can take this example. So there will be, in this orange task, there will be capability under the handle 4. It points to this capability, which kind of has also label 4 in it, and it points to this kernel object, which is called, which is the phone. That's the IPC phone, which represents IPC connections, basically. And this phone is connected to this answer box, which is another kernel
The
object.
blue one is B.
Um,
When I say
Oh, I see. You are trying to match the. You are trying to find the tasks that are. Oh, so this was just. I just made up the identifier here.
Okay.
This picture existed before I drew this one. So just disregard this A. It's something that can be, but it's not necessarily the same numbering as exists here.
So I'm actually trying to match this with the problem I encountered when I prototyped a capability system, which was I had difficulties with well, basically with potential race conditions, with processes that were tasks dying on both sides, and who was pointing to what, and things like that. Whether I should solve that.
Well.
I'm trying to understand if you have the same problem as me, or if you actually need to do that.
So the question is,
maybe I should ask that.
maybe you can take it offline, but let me deal with this. So the question is whether there can be such a situation when I somehow lose track of what capability points to what. So the user space part of the task can of course forget what its capability handles are. It's the same. You can have a set of open files, and you can completely forget like which one is which, right? So this can also happen to you, but since the kernel objects are reference counted, and when the task is killed, it actually cleans up its capabilities. It will result in kind of decreasing the reference counter, and when reference counter in the kernel object, which is not owned by a specific task, drops down to 0, such an object is automatically destroyed. So you don't have to really care about freeing capabilities, because those will be freed anyway when the task is killed. So
and that's more of that.
So do you have any more questions? Just,
elaborate a little bit on the question. What happens when the server dies and we hold the capability for that server's answer box?
So the question is, what happens when the server dies and I hold a capability to that server's answer box? And this is not actually specific to the new code, because such a problem already existed before. I think the phone got slammed and is marked as basically a dangling thing, so that when you attempt to actually send a call over it, you will immediately get an error message. And there is like a symmetric issue, which is what happens when the client disconnects, and in that case there will be a hang up call, which is sent to the answer box.
Well, again, basically it could be related to closing TCP connection. The same principle.
In the case there are no further questions, I thank you once again for your attention.